Welcome to In the Loop, a New England Temperature Solutions podcast. In today's episode, Dom will be joined by Dan Bender, the Director of Sales for Control Concepts. With over 42 years' experience in the industry, Dan brings a wealth of knowledge to any conversation on SCR power control. Today, Dom and Dan will be discussing harmonics. Without further ado, here's Dom and Dan helping you get in the loop.
Hi. Thank you for joining us for our podcast. My name is Dominick DeLuca. I'm president of New England Temperature Solutions. And today we have with us Dan Bender from Control Concepts. Dan, would you introduce yourself? Tell us a little bit about you.
Oh, I'm Dan Bender, and I am the Director of Sales for Control Concepts. And I've been with Control Concepts for 15 years. And we want to talk today about power quality issues, in particularly harmonics.
Harmonic, real exciting topic.
Yes.
Dan, you've been in this industry for 46 years.
46 years,
and
yes.
You've been married for 50-something years?
Married 51 years, and I am the proud father of 4 daughters and 2 sons, and 10 grandchildren with another one on the way.
10 and a half. Wow, that's awesome. That's awesome. And then we go way back. We go back to the 80s. You worked for Robicon.
Worked for Robicon and met you as a result of Robicon had a buy-resale arrangement with Barbara Coleman. Right. And you were working with Barbara Coleman, and Barbara Coleman eventually bought Robicon. So.
Right. And I got introduced to Control Concepts, actually, because we couldn't get Robicon SCRs like a 6 to 8 week delivery, and Control Concepts could get them in a day. So there are some SCRs out there with a Barbara Coleman sticker on them that were blank fiberglass. They printed them for us without your name, and they were sold as Robicons or generic through Barbara Coleman, just because we could get them in a day. So then you went from Robicon to.
I went to Eurotherm.
Eurotherm?
Yeah, I went to Eurotherm after. Robicon, as you say, was part of Barbara Coleman. Barbara Coleman sold Robicon to, at the time, it was a company called CB, which is now Eurotherm. And then Eurotherm sold Robicon to a holding company, and that was for a couple of years. And then the holding company went bankrupt, and Robicon was sold to Siemens. And Siemens sold them, and when Siemens bought Robicon, what they ended up doing is the power control, SCR power control and power systems division, they had no interest in it, and they were going to move away from it. And I got an opportunity and went to work for Eurotherm.
Okay, which is, again, where we met each other again, because we were Eurotherm guys. Again.
Yes.
Right, and then after that?
After that, I was approached by Advanced Energy, AEG, right. And I went to work for AEG, and
you tried to steal me from Control
bring
Concepts
you on board
to
as a
AEG?
rep for New England. And then in 2009, we went into a recession, and Advanced Energy made a decision to eliminate a lot of the positions in North America. And that's how I ended up at Control Concepts and have been there ever since.
And you reminded me that I had actually introduced you to the guys at Control Concepts, right?
That is correct.
Right.
Yes.
I said, would you take this guy and get him out, whatever. But no, you were great. You were a great guy, always very helpful, good service, good support. And you've been a valuable person to work with over the years. So today we're going to talk about power quality.
Yes.
We've got another podcast on power factor and peak demand. But today's is harmonics, and I hate it when I get a call from somebody that has things going on and you can't see what's going on, and sometimes it's harmonic related, sometimes it's noise. So under the category of power quality, you did a paper.
That is correct.
A paper, and tell me a little bit about that paper.
The purpose of the paper is we look at the electrification of industry today, the moving away from fossil fuels to electric. Looking at saying there are some issues that people need to be aware of. So we looked at saying, power quality is one of them, being power factor and harmonics both. So we submitted an abstract. I wrote an abstract. We submitted it to MTI, which is a Metal Treat Institute, to present this paper at Furnace North America show in October. That was that abstract was accepted, and we put together a presentation, and it will be presented in Columbus at the FNA show by our North American sales manager, Tony Bush.
All right. So for them to select it means a couple things. One, it's good, and two, it's important.
Yes.
Right. So
Yes.
it's not a random subject. Oh, this would be nice. It's an important subject based on the electrification. And would you say that's the reason this is top of mind now?
It definitely is, because if you look at, if we are going to take, if you're, particularly like in our industry, we are looking at controlling furnaces with the use of electricity. Okay, the major competition that we have is natural gas, obviously. Well, if you start changing, and it's probably a 60-40 ratio, 60% natural gas, 40% electric. If you make that switch, how are you going to do that? That's what raised the question, because we have an overtaxed grid as it is. How are we going to be able to do that? Well, if it occurs, there are going to be some things people need to look at. And you're going to look at how it's going to affect your power bill, and what are some of the things that'll come into play. That's what generated that we decided that that's what we needed to talk about.
Okay, so your electric bill is impacted by power factor, by peak demand, and harmonics.
Harmonics, yes.
And today's on harmonics. And the 30 years ago, we went around converting everybody to gas.
That is correct.
So I'm double dipping. I've stayed long enough. I'm going to double dip, right? So
the more things change, the more they stay the same. Yeah.
So we couldn't have a podcast with an engineer without an acronym. So PCC, what is PCC?
PCC is something that people need to be aware of. It stands for point of common coupling. Okay. And the point of common coupling is where the utility ties in to an individual company. And that is where they measure and they determine things like that's where your power bill comes from. That's where they determine, if there are penalties that need to be applied, or are you providing and not putting harmful stuff back out onto the line that could affect your neighbor.
Which is today's conversation.
That's where today's conversation comes
into play.
So
what exactly are harmonics?
Harmonics. It's one of those things that's very difficult to grasp. As you had mentioned earlier, it's something that you can't see, but you can see the effects. Harmonics are destructive currents that are flowing in a system. And by destructive, I mean it's heat. It's heat related, and what harmonics will do, you'll see it in terms of overheating of bus bars. You'll see it in terms of overheating of transformers. You'll see it in terms of noise that's affecting sensitive instrumentation, shutting things down. And as I mentioned earlier, when you go to the point of common coupling, not only does the utility look at what you're using and how you're using, but what you may be putting back onto the line. So this destructive currents and harmonics gets put back out onto the line, and if your neighbor is a hospital, they do not want this information, these harmonics coming back, fed back through the line. It's going to interfere with their very sensitive instrumentation.
And I would guess some of their stuff, like MRI units and that, is interfering with my sensitive instrumentation too. So we want to, it's for everyone's safety and well-being that we keep the harmonics to ourselves.
Right, because whenever you're negotiating a contract, a utility contract, it's saying that you're going to deliver power to these, and it's going to be clean power. And if one company is on the same line as another one, and they're creating a lot of this noise, the utility can't provide that quality that they agreed to.
Got it.
So if you're getting noise and setting stuff down, they're going to be contacting the utility, and the utility is going to be coming to you and saying, you got to fix this.
Okay. So what are some of the things that you said, bus bars, anything else that show up as indicators that we have a harmonic problem?
Sure. A big one is that, as we talked about, the utilization of power, and we had mentioned in a previous podcast about power factor. If you have poor power factor, what you need to do then is correct for it. And what common one of this is using power factor correction capacitors. And if you think of a capacitor, it becomes like a sponge. So if you have these harmonic currents flowing through your system, where are they going to go? A lot of times that's where they go. So now you're seeing power factor correction capacitors damaged, destroyed, or it's shutting the system down because they're seeing this, they know it's going to fail, so you have breakers that are taking out your system. So that's a very good indication that this is what the problem is.
Okay, and then for a while your power factor isn't being corrected, so you're getting a double whammy, right?
Exactly.
So what causes? Well, actually, let me talk. A hot bus bar means there's power on the bus bar.
Yes,
and that means people can get hurt. So you have a safety issue as well as.
It's also what is in that general area. For example, we said you have overheating neutrals, you have overheating transformers. Well, if it gets to a certain point where it's hot, you're going to have a fire. You're going to have damage,
because you're not expecting your ground to be hot.
Yes, you don't expect your ground to be hot.
Temperature-wise or voltage-wise.
Right. So if you have that situation, then the potential for fire is there.
Got it.
Yeah.
Okay. Any other ways to detect it? To know that it's there, to be suspicious that it's there?
Outside of those things that's readily available, the other thing is that you monitor for it. If you identify that you have these types of problems, such as the overheating of transformers, the overheating grounds, you're seeing all of that. The other thing is that the utility may tell you. Because if you're putting harmonics back out onto the line, and as I had mentioned earlier, the neighbor is complaining about it, and they're going to the utility, and the utility is going to say, you got to fix this. So what you may be required to do when you sign up for this contract, they may come and say, the power that we are giving you has to meet these requirements. One of those requirements is something called the IEEE 519 recommended practice. IEEE, which is the Institute of Electronic and Electrical Engineers.
Another acronym, thank you.
No. Okay, and what they're doing with this 519 is to help people figure out how you can meet that requirement. In other words, making your system, your facility, more utility friendly. Because if you're putting this noise and stuff back out on the line, it's going to shut you down. Now, as I said before, IEEE 519 is not a specification. It's a recommended practice. However, the utility may say, you need to meet this. Certain standards. And there are different levels on IEEE 519. And there's a lot of things that go into that to make that determination. What level are you expected to meet? What are some of the problems that may occur as a result of you not meeting that requirement? Utility may reserve the right that if you don't, will shut you down.
So that's the opposite of an increase in your electric bill. Your electric bill goes to zero, right?
It goes to zero,
no
and you
power.
have no electricity.
Right,
So
okay.
you can't do anything.
Right.
Not only is it going to shut down things that you were using to heat, it's going to shut everything
You're going to
down.
save a lot of money.
Yeah, you could save a lot of money. Yeah.
Right. So what things cause harmonics?
Nonlinear loads. Okay. And nonlinear loads could be, as an SCR power control manufacturer, phase angle fired SCRs. You're chopping the sine wave. Anytime you take, instead of giving you a full, nice, clean sine wave, you're altering it in some form. So you're only firing for a portion of it. Mm-hmm. Nonlinear loads also are variable frequency drives, UPSs, DC power supplies, a myriad of different things. Anything that's operating that is not using the sine wave in full conduction.
Okay, and they're generating noise. Right?
Generating
I remember as a 12, maybe 13-year-old, we had a light dimmer in the bedroom, and my mom would come in and turn it on, I think. But I remember the AM radio disappearing, going away. Mm-hmm. And I know that today to be because of the phase angle firedness of the light dimmer. Mm-hmm. And the noise that it generated took out that frequency. Mm-hmm.
Well, the noise, as I mentioned earlier, it does can interfere with sensitive electronic equipment. Right. Okay, it causes them to overheat, causes them to shut down. Or if you're looking at, for an example, meters or something, you're getting inaccurate measurements. Mm-hmm. Different things are going to happen. Causes it to misfire. Mm-hmm. SCRs can misfire. Creating a lot of problems. As you could see that.
I would think with digital communications nowadays, if things aren't perfect wired, that type of stuff gets back in and plays with the readings. I've seen, before CE, I'd see monitors do their wiggle thing when it was around SCRs that were firing in phase angle fire mode?
Yeah, you can. A lot of equipment today does have a lot of noise immunity built into it, but not all. It can still impact it.
Okay. So what are the problems? We talked about the loss of utility. We talked about production losses. How do you? Well, we talked about phase angle fired SCRs too, nonlinear. Mm-hmm. So how do the nonlinear loads impact the harmonics? So they generate the noise.
They generate the noise, yes.
Okay. You talked about transformers. And
transformers overheat, motors overheat.
Why do transformers overheat?
Because, again, you're talking, when you look at harmonic currents, they're altering the waveform. Okay. So they're, and what happens, those currents, those harmonic currents, they're wasteful. They're not of any use. But if you heat it up, it's heat, and it creates problems, overheating. So if you have more heat than you need to turn a motor, what's going to happen? The windings are going to get hot. The insulation is going to start to burn up, and you're going to have problems. You're going to shut it down. Also, if you're chopping at that sine wave, if your voltage is distorted, the motor, it may vibrate because it's not operating fluidly.
Mm-hmm. Okay. You talked earlier about transformers having a memory.
Yes.
And, at our age, that's a big topic. But what did you mean by that?
Well, if you look at a transformer, the core of a transformer is expecting to see nice, clean, unidirectional voltage. And once voltage is going this way in this half cycle, then in this half, if it does not, it's not able to support that unidirectional voltage. This is where I said the memory may not be a best indication.
Right, not like RAM or anything, but
it gives you an idea, because what happens is that if voltage was applied in the positive half cycle, it's expecting the next half cycle to be in the opposite direction. Well, if you turn the unit off, you don't know how long it's going to be off. You don't know where it's going to turn back on. So if it turns on in the same direction it saw voltage last time, it can't support that. And what happens is it forces the transformer, it goes into what they call as a form of saturation. Mm-hmm. It's a DC component on the unit. So now that transformer, instead of looking like a transformer, it looks like a shorted load. Mm. Therefore, what will happen is if you're trying to control that primary, say with an SCR, it's going to see it as a short circuit, and you're going to either go into current limit or you're going to trip a breaker.
Mm-hmm. Yeah. Okay. So how do you find these things out? What do you do to test for where you might be having issues?
Well, first off, testing for it is a complicated. It's not an easy thing, and the average person, you and I talking about it, we can identify where some of it is, but do we know all of the details? That's where it comes in, where you need to go to a highly qualified power quality survey company, people that will actually measure and determine what are your power quality issues. And that comes in, they do the survey. It's a complicated thing, and it's not come in 20 minutes and give you an analysis. It's several days of taking a look, because in an operation, things aren't always the same every 15 minutes. It's over a time period. So once they have to make that determination, then they can tell you, here's what your situation is. What do you need to do to correct it? Where do you go? How do you do? What are some of the correction devices that you may be able to use?
And what are those? So what could they tell you to do? What are the examples of that?
Well, you can use harmonic filters. You can put filters on things. You can put chokes in on your line, okay? Or you can go to there are active harmonic filters where you can actually correct for the harmonic condition. The other thing is that you don't need to look at it from a standpoint of device. Yes, this device is operating, it's a nonlinear load, it's generating harmonics, but it's only one in an entire facility. So you may not need to do anything. Just because it's a nonlinear load does not mean you have to correct for it. At that device, are you meeting IEEE 519 at that device? You may not. You don't have to. Where you have to look at it is at the point of common coupling. That's where the utility cares. Utility doesn't care what's going on. They don't care if you have overheating transformers.
But you do.
But we do.
Right.
If you're in time,
the
that's
manufacturer,
important
you do.
for you.
Right.
Yes. So you need to know what that is.
So from a electric company point of view, it can be at the pole, because we get requests all the time because the CE and an SCR by nature, phase amplifier, generates noise and doesn't. They have, there's a little asterisk that, we're CE if you put this filter on it. And
yes,
those filters are big and expensive and come in skids here. We don't like them because we're not designed here to ship skids. But but there's been some talk about putting it at, they should think about a whole company, a building filter, not individual filters.
Maybe not necessarily a whole company, but definitely branches. But definitely not on a device. Obviously, if the device doesn't generate, and then you're not going to have a problem. Right. Okay, so one way of addressing is that we will not have anything come into this facility that's not operating harmonic free. Linear. That's
impossible.
That's impossible, and it's not economically feasible.
Because you can't get heaters that go really hot, that don't require phase amplifier because of current limiting and things like that, right? So
when you start getting in high temperatures, variable resistive loads, that's where you start seeing chopping of sine wave.
Drives and things like that.
Drives, variable frequency drives. So those are things you can do. One of the things is that when we talk about drives is that you go to multi-pulse drives. You can go to an 18-pulse drive, 24-pulse. They address the harmonic issues by phase shifting and eliminating the problem. But again, first off, and this is why the power quality study comes in and is important, you don't have a problem unless you have a problem. Okay, yes, I got harmonics, but are harmonics a problem? Are you having these issues that we talked about, overheating transformers, overheating neutrals, utility threatening to shut you down? If you don't have those, then because you have nonlinear loads and you're going to put in stuff to address the issue when you don't have an issue, that's a lot of expense. Wow. So there's a lot of companies out there that are promoting these types of filters and things, and it's marketing, and not necessarily fixing the problem. It could be you may spend a lot of money to fix a problem that you may not have.
Right. So unless you have safety issues or you're destroying things like capacitor banks.
Yes.
Or your neighbor's complaining because you're sending noise on the line, and then which the electric company shows up, you're probably okay.
Yeah.
Okay. And are there any, from a manufacturing process, you might find that this is impacting other machines? Is that still harmonics?
It could be. You have sensitive machines, sensitive information that you're sending over through, over a network. Okay.
Right.
The harmonics are going in. It's disrupting the network. It's shutting stuff down. Things are shutting down, and you have no idea why.
Right.
And there's a good possibility that is because the harmonics that are in the area. Again, these are signs that you could have a harmonic problem.
Right.
They're not necessarily definite that that's the problem.
Got it.
And that's why it's important that you go to a qualified organization that can come in and do a power quality study. As I mentioned before, trying to fix a problem, particularly harmonics, it's not something that's easily understood. Mm-hmm. So if you can't really identify the problem, how are you going to fix it correctly? Right. Therefore, you need quality people that can come in and do something, give you an evaluation, take several days of monitoring your system and determine what you need to do. Okay. Is it expensive? Of course it is expensive. But as I said before, if you are creating issues and you're sending it back out onto the line, utility could shut you down.
Right.
That's kind of expensive.
And scary, yeah.
Okay. So you need to do that.
So we have a controls engineer that works for us named Andy. And Andy, you had a question.
Yeah, when you have a company come in and do a power quality study, do they just hook up a scope at different points in the plant, or how do they actually monitor the power quality?
That's a good question. What they're going to have is they're going to have sensitive power quality instrumentation power analyzers, and where they're going to go is at the point of common coupling. And they're going to go out there and they will measure to determine, and they will give you not only what harmonic content you have, but they'll also be able to tell you what power factor is.
Okay, cool. Thank you, Andy.
Answer your question?
Yes, it did. Yeah. So they won't come in and like probe at every machine, every.
No. That's what I say. It's important. They're going to, what you want to do when you want to address that issue, it's at the pole. That's where it is, because the utility is really carrying the big stick that could really hurt you, because they could shut you down. Yeah. Okay, you've already identified, if you're going to that point, you've already identified you have harmonic problems. Yeah. Okay, so what are they? How do I fix them? Where can I go? All right, and that's why they go out. They're going to measure at the pole. Now, they may break it down and find, you know what, in this section of your facility is where the majority of this has come. Yeah. So then what they will do, they may move to that particular branch circuit and do the monitoring there. Because you don't, again, it can be expensive. And so do you need a total plant correction system, or is you only need it at certain branches?
Yeah, okay. That was my question.
Great. Yeah. Thank you, Andy. Awesome. Well, I think, did we miss anything? Is there anything else you want to talk about that on this topic?
No, but again, I would have to say, it's a subject that's difficult to understand. You know, there's tons of information out on the web where you can pull down, different people who have done papers on harmonic studies and how it works and what the impact is. Mm-hmm. And I'd recommend you could look at that. Mm-hmm. I can recommend one in particular, which I found very, very helpful. It was done by Eaton Corporation, and it's how to address harmonics. Mm-hmm. It goes through, and it's very intense.
Nice.
But I would say, I have to, this can be an expensive proposition for people. Expensive in terms of possibility of shutting you down. Not only the utility, but internally you have problems going to shut you down. Right. But also, you could spend a lot of money and not fix the problem. Right. That's the biggest thing I would really stress, the importance of finding an organization, a company, that's what they are, reputable and power quality, and give you an analysis and give you recommendations of how you can go about fixing it.
Got it.
Yeah.
All right. Well, thank you, Dan. Thank you for being here.
Thank you.
Thank you for watching. If you have any questions, please feel free to contact us. Our number is 800-848-NETS, or reply to the social media or email that you received this podcast on. Thank you very much.
Thank you for getting in the loop with us. We hope this podcast was informative, and if you need any assistance on anything in the thermal process industry, please feel free to reach out to us at 800-848-NETS. That's 800-848-6387. Or visit our website at www.nets-inc.com to fill out a request for information form. If there are any topics regarding thermal processes that you would like to hear on a future podcast, please send us a comment. We hope you have an awesome day every day.